Welcome to today's tutorial. In today's video we are going to talk about differential calculus. So I have a number of questions with me here under differential calculus. So we are going to solve all of them one by one. So let's begin with the first question. So the first question is saying, find the derivative of the following function, compute the slope of the graph of the function at the indicated points. So if we look at it, we have the first question that is saying y is equal to 3x squared minus 4x at a point of 0, 0. So what does it mean? Now I want you guys to understand that whenever we're talking about derivative, or maybe the first derivative, but just the derivative, when we're trying to differentiate a function, it is represented by dy over dx, or is y, you can use y prime or f prime of x. Okay, so we are basically talking about the same thing. Now if at all I've got y is equal to a to the power n, then meaning that dy over dx is I drop the power, which is n, I keep a constant, then the power reduces by 1. What do I mean? If I've got x squared, the derivative of this, drop the power 2x minus 1, that becomes just 1. So this is the derivative of that. So that's what we're going to be doing. Okay, now let's start with the first one. The first question is saying y is equal to 3x squared minus 4x. Now we want to find the derivative. So then dy over dx, this becomes, you drop the power, that becomes 2 times 3, that is 6x, minus, I drop the power, which is 1 times 4 is 4, then to be x to the power 0, which just remains 4x. Now another thing that I want you to understand here is very simple and straightforward. This is the derivative of that function, but the question continues from here to say compute the slope. The slope is basically the gradient, so we are trying to find the gradient. So the gradient, now you have to plug in the value of x in this derivative function, where there's x, plug in the value of so this is x, this is y. So the x value in that case, I'll say dy over dx, I'll put a line here. When x is equal to 0, what will be the value? 0 minus 4, that becomes negative 4. Using the same concept, I want you guys to go ahead and solve this. Type the answer into the comment section, then I'll be able to see the answer. Now when you differentiate, the x value is negative 3. Let's now go to this third one. Okay, so the third one, I will write it. If x appears down, it's the same as 2 to x to the power negative 3. It's the same thing, because I know that 2 over x to the power 3 is the same as 2 then 1 over x to the power 3. 1 over x to the power 3 is the same as x to the power negative 3. So then dy over dx, I can clearly see that this is going to give me, I drop the power is negative 3, then the power reduces by 1, so it's negative 3 minus 3, that is negative 4. So that becomes dy over dx, that becomes negative 6 x to the power negative 4. If there is negative 4 here, this again is the same as negative 6 times 1 over x to the power 4, of which this becomes negative 6 divided by x to the power 4, like that. Now if that's the case, now we plug in the value. When x is equal to negative 1, what will be the value of y? So negative 6, then negative 1 raised to the power 4, that still gives me negative 6. So the gradient, the slope, is negative 6. That's the gradient. Okay, again we can do the same for the last part. That gives me y is equal to 2x plus 1 over x minus 3x to the power 3. dy over dx. Now here, before we even do this, I will write this. What do I mean? Y is equal to 2x plus, I will write this is the same as x raised to the power negative 1 minus 3, then this is the same as x to the power negative 3. So now I can differentiate dy over dx. That becomes, the derivative of 2x is 2. Then the derivative of this, meaning that 1, when 1 comes here, then it will be x, then negative 1 minus 1, that is negative 2. When this guy comes there, that becomes plus c. 3 times 3, that becomes 9. X, then negative 4, like that. Not so? Yeah. So then I can clearly see that dy over dx will be equal to 2. So this one now, meaning negative 1 is here and x is down here. Even here, plus 9 over, because there is x to the power negative, that negative becomes here. This is the derivative. Now this is the derivative. Now let's plug in the value. Dy dx, when x is equal to 1, so we have 2 minus 1 over 1, we square it, plus 9, then 1 to the power 4. That becomes 2 minus 1 plus that. So that is 1, so this becomes 10. So that's the gradient, that's the slope. So that's the basic idea behind this question. So go ahead and solve this question and send me the answer in the comment section. Let's dive into question 2, which is saying the slope of the curve y is equal to x squared plus ax plus b at the point 2, negative 4 is negative 1. Find the value of a and the value of b. So we have been given the points already. So then it's just a matter of us finding dy over dx. So the derivative of x squared is 2x. The derivative of ax is a. The derivative of b is 0. So any constant number, the derivative is 0. Now we are saying that if we plug in the value of x to be 2, the answer is, that is the slope now, the gradient is negative 1. So that becomes 4. Not so. That becomes 4 plus a is equal to negative 1. So a will be equal to negative 1 minus 4, then a is equal to negative 5. So the value of a is negative 5. Then now, if I go back to the original that I've been given, y is equal to x squared plus ax plus b. Now y is negative 4. So plug in y negative 4. Then x, we already know that the value of x is 2. Now we square it, plus the value of a now is negative 5. X is 2. Then plus b. So we have negative 4 is equal to, this is 4. Then that is going to be minus 10 plus b. So negative 4 is equal to, this gives me negative 6 plus b. Shift 6 to the other side, negative 4 plus 6 is equal to b. Then b is equal to positive 2. That's the basic idea behind that question. Okay. Now let's look at question 3. So we are actually trying to differentiate. These are trig functions. Now I want you to understand one thing. The derivative of, if you have got y is equal to sine x, the derivative of sine x is cos x. Then if you have got y is equal to cos x, the derivative of cos x is negative sine x. If you have got y is equal to tan x, the derivative of tan x is sec x, sec squared x. Now looking at that, we can go ahead and now start differentiating. So if you look at the first one, we have got two functions. We have sine x cos x, meaning that I can use I can use what we call the product rule. So then I'll say let u be equal to sine x and u prime be equal to the derivative of sine is cos x. Let v be equal to cos x, and then v prime should be equal to negative sine x. So dy over dx is given by u prime v plus u v prime. So let's see. We just plug in the values. U prime is cos x, v is again cos x, plus u is sine x, then v prime is negative sine x. So if I cos x times cos x is cos squared x, so this is going to be minus, then sine times sine is sine squared x. You can end here, but what I want you to understand is that this is an identity. So this identity is replaced by cos 2x. So you can end there. Because if you go ahead and also use cos x plus x, then this is going to give you cos, it's going to give you this, because this is the same as cos 2x. Okay. Now, let us go to part 2. Part 2 is saying y is equal to sine 2x. Now, how do we differentiate this? What I want you to understand is that the derivative of sine is basically cos. Now, it's cos, but it's going to be the same cos 2x. Then we multiply it by the derivative of the angle. So we multiply it by the derivative of the angle. So what the derivative of 2x is 2. So the final answer becomes 2 cos 2x. So that's the basic idea. Another thing that I want you to understand is on this question. Y is equal to the cube root of this, then cos x. We have got two functions. Let u be equal to the cube root of that is the same as or it is squared here. It's basically the same as because we know that x to the power half is the square root, meaning that this is the same as x to the power 2 over 3. Okay, then u prime is, now you drop the power reduces by 1. So you are now saying this minus 1, which is the same as minus 3 over 3. That becomes negative 1 over 3. So this is negative 1 over 3. Then v is now cos x. Then v prime is negative sine x. Simple as that. Now let's go ahead and also see how we can find the answer. Using the formula for product rule, dy over dx is u prime v plus u v prime. So that becomes, what is our u prime? It is actually 2 over 3, then x raised to the power negative 1 over 3. Then what is my v? My v is cos x, plus what is my u? X raised to the power 2 over 3, then times v prime is negative sine x, of which this I can go further and finish it like this. If I bring 2 on top, then this is going to be 3 x to the power 1 over 3 cos x minus, because of this negative, x to the power 2 over 3 sine x. So it ends there. If you want, you can end here, that's okay. But again, you can also continue from here and put this one in cube root, even this one in cube root. So that's the basic idea behind that question. Okay. Now let us look at the fourth one. cos squared x. So now how do we differentiate this? We use what we call chain rule. So this is the same as cos x, then we do this. So chain rule state that you drop the power, so this is the power, you keep this constant, the power reduces by 1 times the derivative of what is inside, which is negative sine x, of which this becomes negative, that is going to be negative sine x cos x. But you know that this is an identity. That identity can be replaced by, negative still comes, then 2x, like that. But even if you end here, they will still give you a mark. Okay. Now I think these other questions you can do them, especially this other one, sine y is equal to sine x over 2. So you differentiate y prime, you differentiate this, which is cos x, cos the angle remains the same, cos x over 2 times the derivative of, x over 2 is the same as 1 over 2x. Now the derivative of this is just half. So the final answer becomes 1 over 2 cos x over 2. It ends there. Okay. So other things that we have to know, maybe that other question. Let us also talk about that other question. That is question 5. Now question 5, we are looking at small things. As we can see, we have got y. Let me first get rid of this. We have y is equal to x squared e to the power x. So dy over dx, that becomes, now I want you to understand that this is a function, this is a function. So we'll say let u be equal to x squared, u prime will be equal to 2x. Then v will be equal to e to the power x. Now what's the v prime? If you have got u to the power e to the power u, the derivative of this, what I want you to understand is e to the power u times the derivative of u. So for example, in this case, I'll write first e to the power x times the derivative of x, which is 1. So it just becomes like that. Okay, so then using our formula u prime v plus u v prime, that becomes what? So my u prime is 2x, my v is e to the power x, plus my u is x squared, my v prime is e to the power x. You can end here if you want, but you can also go further and factor out x. You can factor out x e to the power right. Then here you remain with 2. Not so. Here you can remain with 2. I hope this is just okay, what I've done. Yes, that's just okay. So I will remain with 2 here, then plus here I will remain with x. If I multiply this with everything, I'll get back there if you want, but you can just end there. Okay. Again, if you remember this question is similar to this question. So I'll leave it for you. Go ahead and do it and then send me the answer in the comment section. At this point, let's now go and do that. So this one, we're going to use what we call the quotient rule. So the quotient rule states that if you have got dy over dx, if you have got y as u divided by v, then y prime will be u prime v minus uv prime divided by v squared, like that. Okay, now let's go ahead and do our u is x, our u prime is 1, our v is e to the power x minus 1, our v prime is the derivative of this is e to the power x, just like that. Using this formula, y prime, u prime is x, v is e to the power x minus 1, then minus my u is x, then v prime is e to the power x. I divide this by the e, this has to be squared. In simple terms, this now becomes x times this one is e, like this, minus x, then minus x e to the power x divided by e to the power x minus 1, then we square it. But another thing that I want you to understand is that on top there I can factor out x, but I can end there if I want. I can factor out x. I will remain with e to the power x minus 1 minus e to the power x. Like that. But do you know that these, I think these ones can cancel out. Looking at it, they can cancel out. But let's see what we have done. How is this x prime? That was 1, so there is a mistake there. This u prime, u is actually x, then u prime is 1, the derivative of x is 1, so this was supposed to be 1. This was supposed to be 1, meaning that this part here, the answer should be just e to the power x minus 1 minus x, like that. So I can't factor out anything. Then I will leave it there. Okay. So looking at this, if I've given you how to differentiate this, then you can solve this one. You can solve this one. Okay. So if you can solve that one, you send me the answer in the comment section. I'll go ahead and solve part 10. How do we differentiate that? I want you to understand one thing when we're talking about, let's say we have got y is equal to a raised to the power u. So the derivative of that is basically a to the power u times u prime, then times ln a. What do I mean? I'll give an example. Let's just start with this one. I'll start with this one. So y is equal to this, meaning that following this formula, I'll say y prime is, I'll write a to the power x times the derivative of, the derivative of u, which is 1, then again ln a. A in that case is 8. So the answer becomes this ln 8. Same with this one. The first thing is the derivative is, first write this the way it is, then the derivative of that is 1, then ln 2. So the final answer becomes 2 to the power x plus 1 times ln 2. That's the answer. Now let's look at the last one. The last one, like we have said, it is actually y is equal to tan e to the power x, like that. So y prime, the derivative of this, I said it is sec squared But again, at this point, sec squared, then this behaves like an angle, then times the derivative of e to the power x is e to the power x. Okay, so the answer ends like this: y prime is equal to e to the power x times sec squared e to the power x, like that. For the fact that I don't have x here, that's why this is going to behave like an angle. E to the power x behaves like an angle because I don't have x. Okay, so that's the basic idea behind the derivative of exponential as well as trig functions. So let us look at question 4, which is talking about different stuffs anyway. So the first question is differentiate the following with respect to x. Now what I want you to understand there is simple and straightforward. So whenever we are looking at differentiation, especially when it comes from the first question, which is natural log, okay, so I'll just give you the general formula. So if at all I have got natural log of a, the derivative of this is a prime divided by a. So what do I mean? In this case, a is x squared plus 3x minus 4. Then a prime is the derivative of x squared is 2x. The derivative of 3x is 3. The derivative of 4 is 0. So then the dy over dx of that function is a prime, which is 2x plus 3 divided by a, which is x squared plus 3x minus 4. That becomes the answer. Okay, let's go to part 2. Let's see. So part 2, we are still talking about it. So we're going to follow the same principle, but in this case, a is now x squared plus, or x squared times sine x divided by 2x plus 1. Okay, now we are trying to differentiate this. Now what will be a prime? So in this case, a prime will be, which method am I going to use in this case to differentiate this? I'm going to use what we call quotient rule. Quotient rule goes like this: u prime v minus u v prime divided by v squared. Now in this case, again, u is x squared sine x. For me to differentiate that guy, I need again to apply another rule that we call product rule. So product rule states that we are going to differentiate x squared, we keep sine, then plus. So product rule goes like this: u prime v plus u v prime, like that. So I'll assume that u, now forget about this. Now I'll assume that u is actually x squared, so meaning that u prime is 2x. So to create space, I'll do this: u prime is 2x. You keep v in that case is sine x, then plus u is x squared. The derivative of sine, that is v now in that case, that's cos x. Now that's the derivative of the top part. Now that, when I come back to this formula, that is my u prime. Okay, then so this is now my u prime when I come back to this formula. That would mean to say my v is 2x plus 1. My v prime is just 2. So following this formula, u prime, okay, u prime is 2x sine x plus x squared cos x. Then now v, I need to multiply it by original v, which is 2x plus 1 minus, now what is my u? I'll get rid of this. My u is actually the top part, which is x squared sine x then my v prime is 2. This one now, you divide this by, we are dividing this by the v, which is 2x plus 1, but we square it. So now this is lean. So now this, what I have here, everything that I have here, you should take it to say it is a prime. I divide this by the original a, so it's the same as I divide this by x squared sine x, then here 2x plus 1. If I write this, I know that this is going to be, now I'll take the reciprocal, that becomes 2x sine x plus x squared cos x, 2x plus 1, then minus x. I can start this writing this 2 in front, x squared sine x. I divide this by 2x plus 1 squared. Now here I'm doing times, so now I've got 2x plus 1, you get the reciprocal here, x squared sine x. What will be the final answer? The final answer will be, I'll multiply this guy, so that becomes 2x plus 1, you put them in brackets, then put a big bracket, then we still have 2x plus 1, which is this one. Then now I will write this 2x sine x plus x squared cos x. Then I do this minus 2x squared sine x. Then I put a big bracket. I divide this by the bottom part. I have got 2x plus 1. I square it, then times now this x squared sine x. So that is the answer. Okay, so that's the answer which I have there. Now I'm going to do part 3. I'll leave part, because if I do part 3, you can be able to use chain rule and do part 4. Okay, so there we go. I'll do this. Now in this case I'll use quotient rule. So I'll say let u be equal to 3x, then u prime. How do we differentiate? How do we differentiate an exponential like this? So this goes like this. You maintain this times the derivative of the power, which is 1, then times the natural log of 3. Okay, so then v will be equal to 3x plus 2. V prime will be equal to, you keep this times the derivative of the power, in this case is 1, times the natural log of this number. The derivative of 2 is 0, so I'll leave it. So dy over dx, using the quotient rule, u prime v minus u v prime divided by v squared. So u prime is actually 3 raised to the power x natural log of 3. Then v, come on. So I'll put these in brackets. My v is this one, 3 to the power x plus 2, minus my u is 3 to the power x. Then my v prime is 3 raised to the power x natural log of 3. Then I divide this by v squared, which is 3 to the power x plus 2. Then I do that. If I want, I can end there. That's my answer. But if you want, you can expand on top there if you want to waste time. Okay, so in this case I'm going to jump now. I'll go to part v. So I want you to do part 4. Send me the answer in the comment section, and then you are also going to do this one. So I want you to go ahead and look at how do we differentiate the logs. Okay, so it's different from this. I want you to see that. Okay, so I'm going to do this for you. So in that case, so initially, if we look at this, guys, this is basically the same as the one we were talking about here. The only difference here is here I'm going to use quotient rule direct. So I'll say let u be equal to x, then the root of, now that root, allow me to put it like this, raised to the power half, then my u prime. So to differentiate this, I need to apply again product rule. So product rule goes like this: u prime v plus u v prime. But in this case, if you are used with this, it becomes so easy such that if I tell you to say we differentiate the first one, which is the derivative of x is 1, you keep this constant, plus you keep x constant, then you differentiate this one now. So the derivative of this, you drop the power, use chain rule, you keep this constant, then this reduces by 1, which is going to be negative half, times the derivative of what is inside, which is 2. When you reach at this point, this 2 and that 2 can go. What do I mean? My u prime is now, this is the same as the square root of x plus 2x plus 1, then plus x will go on top. Why? I want, now because there is negative on top here of the power, this is going to be on the denominator. So that becomes 2x plus 1 raised to the power half, like that. I hope I've not made any mistake. When I reach at this point, v is e raised to the power x sine to the power 3, like that. Now how do we differentiate v prime? I will still use, these are two functions. I'm going to use again product law. You differentiate this, the derivative of e to the power x is basically e to the power x times the derivative of the power. So that becomes e to the power x still. Keep this constant, plus, then now you keep this constant times the derivative of sine x. Now let's talk about this a bit. This is the same as sine x raised to the power 3. Now how do we differentiate? Drop the power, keep this constant, the power reduces by 1, which is 2, times the derivative of the power, which is cos x. So this becomes 3 sine squared x cos x. So that becomes 3 sine squared x cos x. Now I can go ahead and use my quotient rule to find the answer. So dy over dx, the formula goes like v prime u prime v minus u v prime divided by v squared. Dy over dx goes like, what is my u prime? My u prime is the square root, I'll put it in brackets, square root of 2x plus 1 plus x divided by, again this is the same as putting it in the square root, square root of 2x plus 1, then this is just u prime. What is v? V is e raised to the power x sine, like that, then minus, now original u, that is the top part, okay, that is x, then the square root of, because this I had to change it, so it's the same as the square root of 2x plus 1. Now we go to v prime, so I'll get rid of this. What is v prime? V prime is e raised to the power x, then sine like that, plus e raised to the power. Now in this case, I'll allow me to put 3 here, then it will be like this. Like that. Then I divide everything by v prime, or like v squared from the formula. So my v is e raised to the power x sine to the power 3 like this. Then I have to put this. That becomes my answer. So I'm waiting for you to give me the answer for this and that. Okay, so that is it for question 4. Let's go fast and jump into question 5. That is talking about we have the combination of course, how to differentiate the inverse trig, and then also other principles. So let's start with the first one. So I want you to understand one thing. Then if I have got tan like that, the derivative of this, which is y prime, what I want you to understand is if at all I have got tan to the power -1, which is the inverse, then I have got a as the angle. The derivative goes like this: a prime divided by 1 plus a squared. So in this case, meaning that the derivative of this is actually, the derivative of x is just 1, then 1 plus this should be x squared. Then I'm done. That's just the standard formula. Now if we look at this, we have got two functions. We are going to apply what we call the product law. Let u be equal to x, u prime be equal to 1. Let v be equal to tan inverse of x. Let v prime be equal to, this now becomes the derivative of x. We have already found this in short, so that becomes like this. Now let's go ahead and also look at our formula for product law. Product law goes like this: dy over dx u prime v plus u v prime. So what is my u prime? Is 1. What is my v? Is tan inverse of x, plus what is my u? My u is x. What is my v prime? That is 1 divided by 1 plus x squared. To simplify this, the answer becomes tan inverse of x plus x divided by 1 plus x squared. This is my answer. Okay, let's go to part 2. If we go to part 2, we can clearly see that for sine we use a different formula. Let's say I've got a. So how do we differentiate that? So this goes like this: the derivative of this is a prime divided by the square root of 1 minus a squared. So that would mean to say x, this is the same as that. So we differentiate that, meaning that my a prime in that case is, this is half, this reduces by 1. In simple terms, this goes like this: 1 will go on top. This is now x to the power half, which is the same as 1 over 2 root x. Okay, so that becomes 1, then I've got 2 root x. I divide this by the square root of 1 minus, I square this. Now we are squaring this guy, so if I square this, it's just x, because the square root and the 2 will go. If you want, you can end there, especially if you are not comfortable with math. But for those who feel like they are good in math, they can go further and say this will go like this. This is the same as divided by 1, like that. So again, it will go further and be like this. So again, it will be like this. Then 2 open brackets, this x will be here. Now it will be 1 minus x. You can end here, but even if you end there, it's all right, but the best way is to end there. Now that I've taught you how to differentiate the tan, I believe you can do part 3. Try to solve part 3, send the answer in the comment section. I'm waiting for it. And then let us look at this guy, and we've been doing this. So y is equal to e to the power u. The derivative goes like this: e to the power u times the derivative of u. So what will be the answer there? So it is e to the power tan 2x times the derivative of tan is sec squared 2x times the derivative of the angle, which is 2. Now the final answer is the same one. You end there. Now I want you to go ahead and use quotient rule and find the answer of this last one. So your quotient rule, the formula, like we said, u prime v minus u v prime divided by v squared. So your u is e to the power x squared, meaning that your u prime is e to the power this, then the derivative of x squared is 2x. That is your u prime. I know that the rest you can do. So follow that formula, plug in the values, and find the answer. Okay. So let's go ahead and look at implicit differentiation. So how does implicit differentiation work? It's not that complicated as long as you follow simple principles. So implicit differentiation goes like this: you differentiate the normal way, the way we differentiate, and then where there is where there is y, when you differentiate it, you do times dy dx. For example, let's say I've got 2y squared. The derivative of this is 4y. Now I need to multiply it by dy dx only where there is y. Okay, so let's go ahead with the first one. The derivative of x squared is 2x plus the derivative of that is 2y. Now because it's y, then I do times dy dx is equal to the derivative of any constant number is 0. When you reach at this point, you need to make dy over dx as a subject of the formula, guys. Shift this to go to the other side. 2y dy dx being equal to negative 2x. You divide that by 2y. You divide that by 2y. Not negative, this is positive. These will cancel. Dy over dx being equal to negative 2x divided by 2y. At this point, I can cancel 2. So the final answer becomes like that. So let's go ahead and also look at part 2. Same principle, but now the only problem here is this is 2x. Then here now I need to use product rule because there are two things. There's x and y. So how do we use product rule? You differentiate the first part, which is x. The derivative of x is 1. You keep this constant plus, remember the formula, u prime v plus u v prime. So it's the one I'm following. So u is x, v is y squared. I'm differentiating u, well, that is 1 times the original, that one, then plus, keep this constant, then the derivative of this is 2y times dy over dx, like that, is equal to the derivative of 6 is 0, like that. So this becomes 2x. Because there's plus here, nothing is going to be affected, so we have this. Shift these two to go to the other side, so that becomes 2xy dy dx being to equal to this. So we're dividing both sides by this. Even here we cancel this. Dy dx being equal to negative 2x minus y squared divided by 2xy. That is the answer. After reaching at this point, I believe we can go ahead and look at the next question. The derivative of x is 1. The derivative of sine is cos. So it's cos y, but again, the way we differentiate the trig functions is going to be cos y, then the derivative of the angle. So the angle is, the derivative is 1, but because I'm differentiating y, then that becomes 1 times dy over dx is equal to, again this one I'll use this. So how do we differentiate? You differentiate the u, which is x, as 1, keep this constant, plus keep x constant, differentiate y, that is 1 times dy over dx. Now I'll shift this to go to the other side, 1 to go to the other side, so that becomes cos y dy dx, then minus x dy dx is equal to y, this one, minus 1, this one goes to the other side. Make dy over dx as the subject of the formula. Here I'll remain with cos y minus x is equal to this. Then I'll divide this both sides by this, even here cos y minus x. So my final answer becomes like that. It becomes y minus 1 divided by cos y minus x. That's the answer. Guys, try to do that. The derivative of tan is actually sec squared. So try to do part this one, and I'm waiting for the answer. So I'm going to do this for you. To differentiate this one, remember the formula u v plus u v prime. So I'll differentiate x as 1, keep that constant, plus keep this x constant times the derivative of y, that is 1 times dy over dx, then plus the derivative of this. We have been talking about this, so you maintain this times the derivative of the power, which is 1, but because it's y, then you multiply by dy dx is equal to 0. Shift y to go to the other side. I'll remain with this. Then e raised to the power, here I've got plus e raised to the power y dy dx is equal to negative y. Make dy dx as a subject to the formula x plus e to the power y. This becomes like this. So if I divide both sides by what I have there, I should be able to have negative, this is negative y, should be able to have negative y divided by x plus e raised to the power y. So that becomes my answer. So try to do that one and send me the answer. I'll check it out.